I'm used for torque due to external forces. Is it okay?
Yes.
We are using torque external, torque vector sign Ex. What does this signify? It is a manifestation for torque due to external forces. Is it okay?
Yes, sir.
Yes, sir.
dl by dt, if I have taken a system, if I'm talking of a system and I'm calculating dl by dt, you all are well aware of that dl by dt on a system is owing to only external forces, correct dear?
Yeah, yes, sir.
Yes, sir.
For part of system, it is courtesy internal as well, correct dear?
Yes, sir.
But when we talk of system at large, then it depends only on external forces, correct?
Yeah, yes, sir.
So that being there at the backdrop, I'm furthering from there. Now what I'm to say is if we have no torque due to external forces, what does this mean? Torque due to external forces being equated to zero.
L
We
will be
have
constant.
no torque due to external forces. This implies L for the system will be a constant, correct?
Yes, sir.
Why so? dl by dt is 0. So L for the system will be constant, right? Yeah.
Yes,
Yeah,
sir.
yes, sir.
This gets us or brings us to a very important forum. This is to bring us to a very important inference. And what that inference? The important inference that I'm over here to indicate is when torque due to external forces are 0, then we are to all the forces taken together. Let's say I have taken n forces. They are producing torque, right there?
Yes,
And
sir.
all
Yes,
those
sir.
torque when summed, all those torque when summed, if it is tantamounting to a 0, then we come to a conclusion that dl by dt per se is 0. And if dl by dt per se is 0, then L is going to be a constant. That means angular momentum of system is constant, will not change. Angular momentum being a vector quantity, it will not change in magnitude, nor will it in direction, right? Yeah.
Yes, sir.
Yes, sir.
This brings us to the important point which I was trying to make a significant assertion to, and the point being when L is constant, what we are to say about it being is it is to tell us everything on angular momentum of the system taken. Now, everything on angular momentum of the system taken means if torque external acting on the system is 0, of course, torque external is always taken about a point that goes without saying, right? Yeah.
Yes, sir.
Torque external on a system about a point is 0, then angular momentum of that system will remain conserved. Correct? Yeah?
Yes, sir.
Yes,
Torque
sir.
external is 0. Torque external on what? Please be very careful about the uses of words. Torque external on what? Torque external on system. Due to what? Due to only the external forces, because only they do count, correct?
Yes, sir.
Yes, sir.
Okay, so torque external due to torque external you say, or you say torque due to external forces, when they are to sum to 0, or if they are not acting on system, then we come to a conclusion that angular momentum of this system about the point of reference or point of calculation will remain the same. Remain the same means will not change in magnitude nor in direction, right?
Yes, sir.
Yes, sir. Yes, sir.
This is what is called conservation of angular momentum.
So could you just repeat that once again? Your voice was buffering.
This is what is called conservation of angular momentum, right?
Yes, sir.
Did you ask something, Adesh? Did you ask something? I was just
So
off
could
for a
you
minute.
just repeat the conservation of angular momentum point?
Yeah, the
Because
conservation of angular momentum stems from the fact that dl by dt on a system is only to be taken into account when I'm calculating dl by dt on a system. then what is to be taken only in account is the external force or set of external forces, correct?
Yes,
Yes,
sir.
sir.
Yes, either you say there is an external force acting, or you say there is a set of external forces acting, correct, yeah?
Yes, sir.
Yes, sir.
Whatever the case be, if force is not acting or if the set is to add, as it is a vector addition, you can see for yourself, if the set is to add, if all the forces which comprise the set is to add to get you a null vector, then we come to a conclusion that dl by dt for that system at large is zero, right?
Yes, sir.
Yes, sir.
dl by dt for system per se is zero, then going by calculus, as this is the language of calculus, dl by dt being zero will reflect on what is L, correct?
Yes, sir.
Yes, sir.
dl by dt is zero, what does it translate to? Tell me. What does dl by dt equal to zero translate to? Any one of you? What will it translate to going by the language of calculus?
Sir, change in angular momentum at a particular time delta t is zero.
Yes, the change in angular momentum for the whatever time we have taken, specified time, we can say, right, Krish?
Yes, sir.
So the angular momentum for that specified time is zero. Or we can say that L is not changing with time in totality, correct?
Yes, sir.
Yes, sir. The
Yes, sir.
is zero, then we can also be of the opinion that L is not changing with time, right? I'm coming from the baggage which I'm carrying. Let me make it pretty to you. dy by dx being zero, right?
Yes.
So this is the
Yes,
baggage
sir.
that we are carrying. And if I'm coming from here, Adesh, you have seen this equation few months back, correct, Adesh?
Yes, sir.
So dy by dx if is zero, what is this indicative of? Is y is not changing with x, correct?
Yes,
Yes,
sir.
sir.
Y by dx, as we know in the language of calculus, is rate measured up. We call it rate
Yes, sir.
measured up. How is y varying with x? And the
Yes,
variation
sir.
of y with x is zero. What is this to reflect? What is this to translate? What is this to get you an
That
inkling on? This is to get you an
that Y
inkling.
is constant.
Rather, inkling will be conservative. So let me say, it is to tell you full throttle on what you are to comment on L. And you can go unabashedly commenting on L being a constant. Agree? Yes,
Yes,
So
sir.
your
sir.
screen is frozen.
Okay, so L is a constant, but yes, constant doesn't cut ice. Constant means what to you? Constant about what point, right? Yes, sir.
Yeah.
Yes,
What
sir.
is the point of consideration over here? That is the point which is to be highlighted, correct, yeah?
Yes, sir.
Right, sir.
Yes, sir. What is the point of consideration over here? Point of consideration remains the same. Please be careful of you're calculating dl by dt about a point, right? Because you can calculate torque about a point, right?
Yes, sir.
Yes,
Yes, sir.
whatever you have calculated torque, you are conserving angular momentum as well against the same point. Clear? You cannot say that
Yes, sir.
torque about x point is zero and angular momentum can be conserved about y point. Correct? Yeah.
Yes, sir.
Yes, sir.
Angular momentum is to be conserved about y point, then torque about y point only should be zero. Correct? Yes,
Yes,
sir.
sir.
Yes, sir.
Okay. So this is what is summarized in verbatim as conservation of angular momentum. Is it
Moment.
okay?
Yes, sir.
Yes, sir.
Yes, sir. Verbatim, then we say if external torque acting on a system about a point is zero, then angular momentum about that point of the system will remain conserved. Is it okay?
Yes, sir.
Yes, sir.
That is what we have called conservation of angular momentum.
Moment.
I get all of you. Yes,
Yes,
sir.
sir.
Yes, not to forget that here we are going a step further. By that, what I mean, it is not only conserved, it is rather constant. And I presume you are well aware of conserve and constant. Can I take that liberty?
Yes, sir.
Yes, sir.
Or to read conserve and constant to be the same? What is the distinction between conserved and constant? Any one of you?
The constant
The
means it's not.
constant mean it's not changing, but
Yeah.
conserve it changes. But eventually, if you take the net, whatever is happening, that remains same.
Very
But
good.
constant is changing.
Very exactly. So if two particles do collide, and the collision is elastic. Elastic means kinetic energy remains conserved. Is it okay? So if
Yes.
two
Yes, sir.
particles are colliding, now I'm going to slightly digressing from what we are because I need to get that point across. And the point being, suppose you are to collide with your friend. You are moving with some speed, your friend was also moving with some speed. You are moving with 7, your friend was with 5. Is it okay? So you
Yes.
Yes,
collide.
sir.
Collide with your friend and the two of you collide head on. Is it okay?
Yes, sir.
Yes, sir.
Now, when you collide head on there, then of course you will try to set your terms. That means if you are moving with 7, then you will try to make your friend also catch with your speed, correct?
Yes, sir.
Yes, sir.
Yes.
You will try to push him. You will try to push him so that he is pushed to your speed. He or she is pushed to your speed. Agreed, yeah?
Yes, sir.
Yes, sir.
And what will your friend try to do? He or she will try to set her or his term. Can we say that?
Yes, sir.
Yes, sir.
So if it is so, in that case, the person is to try reduce your speed. Can I say that?
Yes, sir.
Agreed, sir. Yes, sir.
Okay. He or she, I said, you can flip it. So this is what I meant to say, that you are trying to set your term by increasing the person's speed to 7. You will be always in pursuit to somehow make the person in agreement with your speed, and the person on contrary will try the other way, correct?
Yes, sir.
Yes,
Yeah,
sir.
yes, sir.
Till the time the two of you are in mutual agreement. Of course, it cannot be either 7 or 5. Till the time the two of you are in mutual agreement, what are you trying to do to the other person? You are trying to impress upon the other person. Can I say that?
Yes, sir.
And
Yes,
the
sir.
other person is trying to impress upon you, right? Yeah.
Yeah.
Yes, sir.
Yes, sir.
Okay. Now let us say the mutual agreement is on speed 6 meters per second. Fine, yeah.
Yes, sir.
Yes, sir.
Yes, sir.
You are moving in the same direction, your friend with 5, you with 7, and then you did hit your friend, you try to impress your point, your friend on contrary try to impress her point, and eventually you got into an agreement, your friend got into an agreement, and the agreement being fine, both of us are to move with 6 meters per second in the same direction, of course, right? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Tell me, when both of you are moving with 6 meters per second, are you any further trying to press upon your friend?
No.
Any further?
No,
Once
sir.
there is an agreement, are you still into buttressing your point of 7, or you will be honest to the agreement signed?
It would be honest. So,
Honest.
to be honest with you, agreed.
Not trying to impress upon your point any further, correct? Yeah, neither your friend should, correct?
Yes,
Yes,
sir.
sir.
That
Yes, sir.
both of you are now happy in your skin, moving with 6 meters per second, which is suggestive of the fact, if I go into the physical front, it is suggestive of the fact that the two of you are not pushing upon each other, correct?
Yes, sir.
Yes,
Agreed,
sir.
sir.
Pushover over here, none could have been pushed over. So you all came to, both of you came to a mutual agreement, and now you are not impressing any force upon each other. Both of you are moving, touching each other, you are moving, but you are not pressing upon each other, correct? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Before of attaining mutual agreement, what were you trying to do? You were trying to deform the other person. Can I say it on the crude front? If I'm taking on the crude front because I'm to get into the physicality over here, then what you're trying to do, you are trying to deface the other person because you're trying to push upon the other person, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Your friend was also no at all, not in the mood of relenting. So if the friend was not in the mood of relenting, not in the mood of buzzing, then the friend was also pressing upon you, thereby defacing you as well, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
So what's happening to if I deface this bottle? Let us say there's a bottle with me and I'm trying to deface it. Is it okay? Are you
Yes,
getting
sir.
it? I'm trying to
Yes, sir.
deface it. I'm trying to deface it. Then what I am on physical front into doing is work. On physical front, if you take this experimentation on physical front, then what I'm trying to do, I'm trying to do work, correct?
Yes, sir.
Yes,
Yes,
sir.
And
sir.
that work, if the body gets defaced, if the body gets defaced, then that work is stored in this body in the form of potential energy.
Yeah.
If the body gets
Yes, sir.
defaced, then the work that you have done is stored in the body in form potential energy. Clear, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Why did I say potential energy? Because the work which is being done by you is absorbed by body and it is retained by it, correct?
Yeah, yes, sir.
Yes.
The body has got now the potential to do work. Can I say that? It
Yes,
is
sir.
stored in the
Yes, sir.
potential energy means the body has energy with it. It can make good of that energy, correct? Ivan?
Yeah.
Yes,
Yes,
sir.
sir.
Now, to make good of that energy or not, that is completely body's prerogative. If it tries to make good of that energy, let us say body is elastic, then what will it try to do? It will try to make good of that energy. That means the potential energy will later reflect in form of kinetic energy. Getting it here?
Yes,
Yes,
sir.
sir.
Yes, sir.
High kinetic energy because till the time when the two of you were pressing upon each other, both of you were deforming each other, right there?
Yes, sir.
Yes,
Yes,
sir.
sir.
Now, when you started moving with 6 meter per second, then you are no more into deformation. Can we say that when the two of you are moving with common speed, that is the time when the system will come to acquire maximum deformation state?
Yes, sir.
Getting it or not? When the two of you are moving together with 6 meter per second. Now you are in agreement, but still you have not regained your original shape. Why have you not regained your original shape? Because you are touching each other and moving with 6 meter per second, correct? So what is the
Yes.
state of system? The state of system is called maximum deformation or maximum potential energy. Why maximum potential energy? Because deformation is maximum, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now what happened? Think about it. If the two of you are elastic, then you will try to regain your original shape and size, correct?
Yes, sir.
Yes, sir.
You are made of elastic material, then you will try to regain or reclaim your shape and size. When you try to reclaim your shape and size, this is the time when the two bodies in contact are to part. Are you able to understand here why the two bodies in contact now are to part? Because you will try to gain your shape and this body will
Yeah.
also try
Yeah.
to gain its shape. Correct? Yeah, are you getting it?
Yes, sir. Yes, sir. Yes, sir.
What
Yes, sir.
happened? The two bodies are now to part. And if they are to part, parting is very subjective, mind you. If you are plastic in nature, that means if you don't have any tendency to regain your original shape and size, then you will have no inkling to part. Why? Because you are happy in your skin moving together. Yeah.
Yes, sir.
But if you have that tendency of regaining your shape and size, then of course will part. And when you will part, basically what you will be doing is you will be increasing kinetic energy of system at the expense of potential energy stored in you. Agree?
Yes,
Yes,
sir.
sir.
Yes, sir.
Now,
Sir, my
as you
doubt.
are regaining your shape, you are less on deformation. So, what has happened to your potential energy? It has decreased. And what form it is to reflect? It will reflect in the in
And
form of kinetic energy. Can we say that?
Yes, sir.
Yes, sir.
So as it is reflecting in form of kinetic energy, what we can say on kinetic energy, that is what was the moot point. We can say about kinetic energy being constant through and through collision, or we can say kinetic energy will remain conserved. What you can say?
Remain
What you can
conserved.
So
elastic
conserved.
collision.
Sir.
Elastic means kinetic energy will remain conserved, by the way. So can I also say, as asked S.C. Verma, that can I also say that kinetic energy will remain constant for the system? What is your take on it?
So I'd say it remains conserved for the
Yeah,
system.
consider only, sir.
You say that will remain conserved, and that is the distinction between conserve and constant. Had it been constant, if I was to pick on constant, then kinetic energy was not to change given any point in time, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
But we saw that we did see, we saw during the course of collision, right dear? We did
Yes,
see
sir.
or not
Yes,
dear?
sir.
We saw during course of collision that there was some kinetic energy which changed to potential energy, and eventually, if it is elastic, will reclaim its initial value. If it is not, it will be falling short of that reclamation. Correct, yeah?
Yes, sir.
Yes, sir.
So your
That is the
screen is
distinction
frozen.
between conserved and constant. Why did I bring
So, and
that
your
point
voice
to
is also breaking.
now? We are going superlative. Yes,
Your
Adesh?
voice is breaking.
Okay. Okay, just a minute. It's fine now?
Which
Is it good now? No,
no,
Adesh?
sir.
Okay.
Not. No, sir.
Okay, just a minute.
Krish, can you hear, sir?
I am able to
Yeah,
hear you.
I can hear,
I'm
sir.
able
I
to
can
hear
hear,
you
sir.
clearly. Krish, are you able to hear me?
Sir, you're seen also, sir.
Come again, dear?
Sir, you're seen. Your screen is clear for me.
Okay, will you please check your net connectivity, Adesh?
That's still
Vedant,
not fine. It's
to
still
you,
frozen.
Vedant?
Yes, sir. It's clear.
Okay. Check Adesh once. Because you are clear to me, Adesh, by the way. Adesh, am I audible?
Krish,
You may rejoin. So we were referring to L being constant, right, Krish and Vedant?
Yes,
Yes, sir.
sir.
Okay, so L is constant, and you know when can we use this? And this principle, if you find L to be constant, is called or read as conservation of angular momentum. Fine?
Yes, sir.
That's conservation of angular momentum. Now, we studied a question the other day. What was that question on? That question was on sphere. A sphere which was rolling with slipping. Can you recollect?
Yes,
Mm,
sir.
yes,
A
sir.
sphere which was rolling with slipping. Let me mark the omega naught value, V naught by 2R, and this was given V naught to us, correct?
Yes, sir. So
This
Adesh joined.
question, yeah. In this question, yeah, we solved it, and you know how did we solve? What I ask you now is to solve the same question, but the question which we solve it by using V is equal to omega R, solve the same question, but with conservation of angular momentum in the backdrop. So can you solve this question, the question that we have solved the other day, with a hindsight? And the hindsight being, I will be using conservation of angular momentum, which I have read just now in the solution. So how will you use conservation of angular momentum in this solution? Let me ask you on number of forces acting on it. You are quick on it, you will say normal will act and will act in this direction, will act mg,
mg.
will act in this direction, and also we have effects, right? Yeah, we
Yes,
did
sir.
so. I think we did see about Fk acting.
FK, yeah.
Okay, what was the direction of Fk shown?
Backward.
So backwards.
Was it
I
backwards?
think minus icon.
Okay, so Fk was seen acting backward, right? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
Now, this how
Screen
we did
frozen
solve. I'm
again.
not going into it because I have asked you to always be in the mode of writing. So I presume is there with you now inculcated. If not inculcated, please cultivate it to the earliest. Now, Fk is acting in the backward direction. V naught, omega naught. These are known to us. Good enough. What I deem ask you is, what is torque about this point? Any point on horizontal ground. I have picked on a stray point on horizontal ground. Anyone having any issue with it? Any stray point.
So, but
I
one
have
doubt,
picked
why?
on any stray point. Any stray point. Right,
No,
dear?
but why did you take only that point? Like, why on the horizontal ground? Why not anywhere else?
Yeah. Why on the horizontal ground? I have a reason for it, which I'll reveal later. For now, any issue with taking that point? Why specific I am to horizontal? I'll come to it. But if I am to take horizontal and I have taken anywhere on horizontal, I don't think I deserve a raise a question on this point.
No, sir. It's okay. Yes, sir.
No, sir.
So in that case, what are the forces which may produce torque about this point? You will say normal mg and fk they are acting. Then we'll
Yes, sir.
ask, can Fk produce torque about this point? What
No.
say you, Krish? Can Fk produce torque about this point?
No, sir.
No, and I think I have answered your question. I have asked to pick on a point, which is to see torque acting about its zero. Clear?
Yes, sir.
I have asked to pick on a point which is incommensurate with torque calculation getting us to a null.
Yes, sir.
Now, Fk, of course, will get you zero torque about point P. But we are yet to see for normal and Mg. Normal will produce torque about point P or not. Normal will produce torque about point P or not. Think about it, point P. P is out here. Normal this. Line of action of normal is known to you. Perpendicular distance also known to you. So
Yeah, it
tell
will
me,
produce.
normal will produce torque or not? Yes or no? All of you please
Yes,
do
sir.
answer.
It will produce.
Normal will produce torque or not, Adesh?
So,
Normal will produce torque or not about point P. I'm calculating torque about point P. Please be specific. And all of you, please,
yes, sir.
you for the last time now. I want my students to reciprocate whatever I do put in. So please get into the mode of studies, and not only you are to keep to the number of hours which is IIT asking for, but at this point in time when you are in luxury, you need to go beyond it. Please don't read me as going over the top. That is the need of the hour. Am I amply clear to all of you?
Yes, sir.
Yes, sir.
Yes, so please get into the mode. I need not repeat it. Tell me what is your take on torque due to normal about point P? Can normal produce torque about point P or not? Yes, Adesh.
So I'd say it can. Oh,
It
no,
can.
it can't.
Okay. You said it can, right?
Yes, sir.
Okay. And Vedant, what about MG dear? Can MG produce torque about point P?
Yes, sir. Yes.
Yes, they can. And you very well know what is torque magnitude wise, correct dear?
Yes, sir.
Normal
Yes, sir.
multiplied with perpendicular distance. Let us say this is x for instance. So normal into x. Similarly, mg into x will be torque due to mg, correct?
Yes, sir.
And Newton's second law of motion says that normal will be equal to mg, right?
Sir.
Yes,
Yes,
sir.
sir.
Okay, so normal is trying to rotate the body clockwise about point P. Agreed?
Yes, sir.
Yes, sir.
Point P, normal is trying to rotate body in what sense? Clockwise. And mg
Yes,
on
sir.
contrary is trying to rotate it anti-clockwise. Agreed or not?
Yes,
Yes,
Yes, sir.
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 Thereby, what we can say, of course, individually they are ought to produce, but collectively they will get us a nullification, a null vector, right there?
Yes, sir.
Yes,
So
sir.
can we say torque produced by normal is neutralized by torque produced due to mg about point P?
Yes, sir.
Yes, sir.
Yes,
So
sir.
Okay.
if it is into neutralizing, then net torque about point P is therefore zero, right?
Yes, sir.
Yes, sir.
Yes, sir.
You want to find a point and we got myriads of point about which torque will be zero. Yes, those points must fall on the horizontal road, correct? Krish,
Yes, sir.
that's the reason we have taken the horizontal road as reference, right, Krish?
Yes, sir. So can we take point of contact?
Yes, we can take point of contact as well as reference. No issue.
Yes, sir.
That will be no different from a point housed by horizontal, right? Yeah.
Yes,
Yes,
So
sir.
you can take any point housed by horizontal floor. You will get torque about that point for this system on null vector. Clear?
yeah,
Right.
yes, sir.
Which qualifies us, which equips us with the uses of conservation of angular momentum. Can we say that?
Yes, sir.
So we do qualify the uses and can say that angular momentum of this system about point P will remain conserved, right there.
Yes, sir.
Yes, sir.
Please write that down. Angular momentum about point P for the given
Right.
system will remain conserved. Will remain conserved. And if angular momentum remains conserved, then what is to take place when body is to rotate and translate, keeping V is equal to R omega established and intact? Think about it. The body now, after some time, got into the state of pure roll, and the body is rolling without slipping. It is to maintain that state, you know, that once pure rolling is to get established, the status is maintained. It is therefore on status quo hitherto, correct? Yeah.
Yes, sir.
Yes, sir.
Yes,
Status
sir.
quo will persist. That means there will be no friction acting and body will continue to roll without slipping, right?
Yes,
Yes,
sir.
sir.
So
Yes,
let
sir.
me ask you, if the body has attained pure rolling state, omega V and the relation V is equal to R omega has been established and is maintained, is intact, right? Yeah.
Yes, sir.
Yes, sir.
And I wish calculate angular momentum about point P again. This is the point. I wish calculate angular momentum about point P again. Clear?
Yes, sir.
Yes, sir.
How do I get angular momentum is what you are to pay heed to. Am I clear? It's very
Yes, sir.
important. That's the reason I have raised that point before of articulating it or asking you to write. What is important over here is to see how the angular momentum equation changes or what best we can do so as to change it to our suit. Am I clear?
Yes,
We are
sir.
changing it
Yes,
to
sir.
our suit. We are changing it to make virtue out of our knowledge. And that is what is of import over here against this question. First things first. If I am to calculate angular momentum about point P, There is only one formula at my disposal. Can you highlight that formula? There is only one formula at my disposal. I don't have any other mean. I have only one formula at my disposal. And I have told you that being the mother equation. I have told you and given the epithet of it being mother equation. Please don't get those concepts lost on you. Am I clear?
Yes, sir.
Yes,
Okay,
sir.
so let me, what is the mother equation? L is equal to what about any point?
L is equal to
So
LCM
L
plus
is equal to L prime plus RCM into MVCM.
Yes, plus RCM cross M into VCM.
Two.
Adesh, I wish you could have told me from your memories. You are not, I know you referred somewhere, but please pay heed to what being asked. These are now to be committed to memory. I'm not casting aspersion, I'm just guesstimating. So I'll be more than happy if proved wrong. Tell me, did you refer or not?
I did not.
Okay, good then. So L is equal to L prime
So
plus
was
RCM cross M into VCM. And this is what Adesh did tell me. I'm going to use it now. Tell me, dear, what is L finally? Is I naught into omega minus K prime. Can we write for L prime this term?
see the screen.
I naught means moment of inertia about an axis passing through center. And omega, whatever it gets to finally, is being marked. And you know if the plane is xy, then into the board will be minus k. Agreed?
yes, sir.
Agreed, all of you? First part, only
Yes,
L
sir.
prime. All of you, Vedant, Adesh?
Yes, sir.
So your screen
Adesh?
is blurry for me.
Agree, did
Yes,
agree?
sir.
Blurry. Okay.
Krish, is the screen fine for you?
Yeah, it is fine for me. I'm able to hear his voice too.
Yeah, I'll just leave and I'll join.
Yes, just
Okay. Okay. Now look at the point, please. Which point? The center of mass. Clear, dear?
yes, sir.
Adesh, am I audible now? Is the screen clear here?
So you're audible. So it's my connection problem. I'll start
That
using mobile
is
data from
smart or is reinstated. Able to view the board.
my voice.
You're not able to. Oh dear, you need to do something for your system. Any luck, Adesh?
No, sir. But I think I'll manage like this. I can manage.
Do
So
something.
no, it's my
Adesh, you know that this is going to be the order of day now for about 4 to 5 months. So you need not get this point dismissive. You need to address it. Correct? Yeah. Do something
So I'm
about your
using mobile
connectivity.
data for next week.
Yeah, please do something about it. Well, this is going to be the order now, as you know very well. Correct? Okay. Now, next point here. What is RCM cross M into by? This is going to be the order. I meant that online classes are now in fad and they are to continue. This is the order now for at least 4 to 5 months. So we cannot be dismissive of any ask on technical front. Please get it arrested as early as possible. Right, Krish?
So
I
the
sorry.
schools
Like
will be
Adesh. Adesh.
Yes, sir. Yes.
the schools will be opening by September.
Yeah. It will not be. Nothing is going to get back to normal before of October. In fact, I think this entire of the year will be a washout.
Oh, okay.
Washout on the front that schools are not to engage with organic classes.
So someone told me it'll open in June. That's why.
No. June will not be the June. They will open sporadically, but June and July is to see as per what they are extrapolating from data. They have data and extrapolation being July, June is to see the peak. So after a peak also, it is not that it is to die instantaneously. It will take phases to frizzle out. And phases to frizzle out means it will go up to November. I think normalcy can be stored only towards the end of October. Uh, there's no point. Anyway, whatever it, as and when it falls, we are to change. But for now, we are almost sure on there being to the least 3 to 4 months that we are to move on this mode. Okay, now tell me RCM cross M into VCM. What about this one? I told you, if you can recollect, that when we calculate the second factor, then we are dismissive of the dimension body possesses, correct?
Yes,
Yes,
sir.
sir.
Because the body then shrinks to a point, right dear?
Yeah, yes, sir.
So in adherence to what I have said, let us shrink this body to a point. And if we are shrinking to a point, where is the body to be, where is the point to be placed? Of course, at the center of mass of body or given body, correct?
Yes, sir.
Yes,
Now
sir.
it will be RCM cross MVCM. LBM into V into R in the direction minus K cap again, correct?
Yes, sir.
M into P into R in the direction minus K cap again. We have seen this several times. So I'm not going into diligence again. Is it okay? R
Yeah,
plus
yes,
MV
sir.
about any point, you know that very well. Yes. Also we know that finally when pure rolling is established, then V should equate to omega R, correct?
Yes, sir.
Sir.
So when pure rolling is established and we are viewing from Earth and they are incommensurate with each other, by incommensurate I presume you will be able to decode and get to what I'm trying to suggest. Correct, yeah? Incommensurate means point of contact should not move, right? So
Yes,
if
sir.
it is forward, then omega should be clockwise, correct?
Yeah, yes, sir.
We are assuming that V is forward and omega is clockwise. In that case, what we end up getting is I naught into omega minus K as it is I am to keep. And now V is to be changed with R and omega. So M omega R square direction minus K cap. Fine.
Yes, sir.
And we are meant to see I naught plus MR square taken in bracket with omega common. Can we check once?
Yes, sir. Yes, sir.
Okay. So this that we have got in the brackets, I naught plus MR square. The one that we have got in the bracket, I naught plus MR square. We will prove that this is nothing but moment of inertia about point of contact. We will prove it that this is nothing but moment of inertia about point of contact. And as said, if you are to pay heed to what I'm advocating, then the term in bracket can be replaced by I prime and omega vector is what I am replacing omega minus cap for. Find here.
Yes, sir.
So what do we get from here? LP is equal to IP prime into omega, right?
Yes, sir.
And this is similar to what you got. Now this is important. This is similar to what you got as angular momentum about axis of rotation for a rigid body, right?
Yes, sir.
If I take the body to be symmetric, then I'll be using vectors. If I'm not taking body to be symmetric, then I'll not be using the vector. That's the only caveat, right? Yeah.
Yes, sir.
Yes,
But
sir.
I can say in any case that L about the axis of rotation is product of I about the axis of rotation into omega about axis of rotation, correct?
Yes, sir.
Yes, sir.
So what can I get from any one of you? What can you infer intelligently from here? What can you clear the hedges and see what I'm trying to suggest or what is into coming? Anyone? Can you preempt? Can you preempt something which I am trying to pull you to? Some point I am trying to make, some point I am trying to push to you. Can you preempt what is that point? Any one of you. Now, when is IP into omega to be taken into adherence? You know,
So
when the body is, when a rigid body is rotating about fixed axis, correct?
yes, sir.
And when is this formula to be taken for any case, correct?
Yeah, yes, sir.
Yes,
This
sir.
formula applies to all the cases possible, right? Yeah.
Yes,
Yes,
sir.
sir.
Okay. And what did this formula? This formula only. I began from here, right? Yeah.
Yeah, yes, sir.
So what did this formula shape to? This formula did shape to IP prime into omega for us.
Yes, sir.
Now IP prime into omega is splitting image of L is equal to I into omega. Can I say?
Yeah, yes, sir.
And L is equal to I into omega, we are in compliance if and only if a rigid body is rotating about fixed axis.
Yes, sir.
So can I make a statement over here that P is P prime, that P prime is a point about which given body is in pure rotation? Can I make that statement? Please try to understand. By the way, this should not be P prime. This should be P prime. Here I have taken it to be slipping, right? So this is P prime. I have taken V is equal to R omega. So this is P prime to us. Correct? Yeah.
Yes, sir.
I'm getting it. P prime is that point to us. And what I'm trying to ask you is that LP when I find, LP I'm finding, I'm going LP, 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 and I got over here. P prime I've written because I have to prove that this is equal to P prime, which I'll be proving. I have told you. Correct? Yeah. If
Yes,
you
sir.
take it on face value for now, which is imperative of you to do, else I'll not be able to move further. If I'm assuming that this is nothing but moment of inertia about P prime here or P prime here, then moment of inertia about this point into omega. What is this suggestive of? Is this not suggestive of that the body is rotating about P prime? Because L that I got is similar to what I got for a body rotating about fixed axis. Can you recollect?
Yes, sir.
So can I make a statement over here that point P prime is the point about which body is in pure rotation, about which body is under pure rotation. Think about it here. More will P prime relate to this point to you, mind you. Why I'm telling you more will it relate to this? Because I've used V is equal to R omega. Clear?
Yes, sir.
And where is V is equal to R omega established? When body
Impure.
is under pure
Pure.
rotation. Clear?
Yes, sir.
Yes, sir.
So related to this state, when body is under pure rotation. And then let me ask you a question. If body is under pure rotation, then P prime is at rest, correct?
Yes, sir.
And if P prime is at rest, then owing to the equation which I get, what can I infer? What can I from here extrapolate? I can extrapolate that P prime is fixed axis to me. Agree? Think about it. P prime is fixed axis to me. Fixed axis about which the body is under pure rotation. fixed axis about which the body is under pure rotation. Did I say pure rotation, anyone? Why did I say pure rotation, anyone?
Because V is equal to
Because
R
I
omega.
got the equation LP is equal to IP prime into omega, correct?
Yes,
Yes,
sir.
sir.
And this equation we have seen, we are getting a deja vu feel. We are getting a feeling of nostalgia hit. Why so? Because we have seen this equation 3 classes ago, correct?
Yes, sir.
Yes.
Where I did advocate for this equation is for all the cases when the body is rotating about fixed axis, correct?
Yes,
Yes, sir.
sir.
If I am to take a cue from there, then we can very well say that about P prime, this body is executing pure rotation. Think about it. About P prime, this body is executing pure rotation. It
Yes,
doesn't in any way be confused with, please don't be illusioned that it is actually into pure rotation about P point, about point P prime. Of course, it is not actually into pure rotation about point P prime. So what is into? It is for that moment. It is for that moment. Which moment? The moment when you look at it. When you look at a wheel which is moving on road, then you are to see for the point P prime. P prime is the only point which is in contact with road. Now, what will you say about P prime? If you muster courage of placing your finger beneath tire, don't do that, otherwise the finger will pulverize. But if you muster courage or if you can guesstimate what is to happen, one thing that you will for sure be able to comment on is your finger will not be rubbed. Tire will press upon your finger. Tire may pulverize your finger, but tire will not rub your finger. Till the time tire is skidding, it will not rub your finger. Agreed or not?
yes, sir.
Yes.
And if it is not rubbing your finger, what is this indicative of? This is indicative of that point of contact is at rest, correct?
Yeah, yes, sir.
And we know very well that pure rolling means point of contact being at rest, correct?
Yes, sir.
So what is the state of body here? Pure rolling, right here, right Adesh? What is the
Yes,
state
sir.
of rolling here? Pure rolling, right Adesh?
Yes, sir.
And if it is pure rolling, what you can say about P prime? P prime is at rest, correct?
Yeah,
Yes,
yes, sir.
sir.
Does this in any way translate to P prime being at rest ad nauseum till eternity for every
No,
time that we are looking at P prime? Does it what I am to suggest?
no,
Is it what I am suggesting that P prime will forever be at rest? Is
no,
that
sir.
what I am suggesting?
No, sir.
No, then what I am suggesting? I am
No, then
suggesting that whichever point comes in contact with ground, of course, points are to change. Ad nauseum, incessantly point are to change. Can we say that?
yes, sir.
Incessantly
Yes.
points are to change. Say yes or no.
Yes,
Yeah,
sir.
yes,
Yes,
sir.
sir.
Any point which is coming, whichsoever point it may be, the point when comes in contact with ground is at rest. Agreed or not?
Yes, sir.
Yes, sir.
And what is the state of rolling then? When I'm saying that the points which are coming in contact with ground are all to be seen at rest at that moment when it is touching ground, then what is the state of rolling? Pure rolling or rolling with slipping?
Sir, I
The
don't
pure
understand.
rolling, right?
So,
All of you please tell me what is the state is then? Pure rolling or rolling with slipping?
the pure rolling.
Pure
Pure
rolling,
rolling.
right?
Yes,
Adesh?
sir.
Yes, sir.
Okay. So as this body is under pure rolling state, what we can say about P prime? P prime is at rest. And if P prime is at rest, which it is, then P prime is called instantaneous center of rotation. Then P prime is called instantaneous center of rotation, ICR. P prime is called instantaneous center of rotation, which is in short marked with initials ICR. Clear?
Yes, sir.
Yes,
And if
sir.
I take an axis passing through P prime, then this axis is called instantaneous axis of rotation. Is it okay? What is this axis called? Instantaneous axis of rotation. Am I clear, class?
Yes,
Axis, which
sir.
axis?
Instantaneous axis of rotation.
Which is the axis as shown in the figure?
This is the axis passing through point P perpendicular to the plane of figure.
Yes, sir.
You can assume it to be a cylinder, dear. And if you assume a cylinder, then there are myriads of points which are at rest, correct, dear?
Yes, sir.
Connect all those points, you get an axis, correct?
Yes, sir.
The axis will be called instantaneous axis of rotation. Fine, dear?
Yeah, yes, sir.
If there is only one point, then more is to relate instantaneous point of rotation. If you have got multiple points, join them all, you get an axis, you get a line, correct?
Yes, sir.
So it is up to us to take this as point of rotation or axis of rotation. Clear?
Yes, sir.
Yes, sir.
Okay. So what is instantaneous about it? What is so instantaneous about it? Anyone? What
So
is
just
instantaneous to do here? Why the precursor? Why
there.
the pretext? There's a pretext. It is not called axis of rotation, rather is instantaneous axis of rotation. So why that pretext? Any one of you?
So because
Is it because the point, that particular point, is in contact with the ground for an infinitely small amount of time?
Yeah, exactly. Good, Adish. Because the point which we are referring to is in touch only for fraction of second. Correct, yeah?
Yes,
yes, sir.
sir.
Yes, sir.
After of that, what happened? Another point will be then given this epithet. Correct?
Yes, sir.
So points which are given this epithet are to change with time. And this is incessant change. They will keep on changing. So for the time which point is in contact, for the time that I have taken the clip, which point was in contact? P prime.
P
So what
prime.
is P prime to me? P prime for that time is to do an instantaneous axis of rotation or instantaneous point of rotation. Correct, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
That means about P prime, what can I assume? Anyone? About P prime, what can I assume is happening? What motion the body is exhibiting about P prime?
Pure rolling.
Motion the body is exhibiting about P prime. All of you, please. What motion the body is exhibiting about P prime? Vedan, tell me.
So
What
pure
motion is
rolling.
the body exhibiting? Of course, at that instant only. Instantaneous being there, that part is addressed now. So at that instant only, what kind of motion the body is at that
So,
instant about P prime?
so pure rolling.
Pure rolling, no, not pure rolling. Not pure
Do
rolling.
we
Body
say it's
is
at
under
rest?
pure rolling, that is equal to R omega. Correct yourself, Vedant. Re-evaluate your answer.
Sir,
Correct
could you
yourself,
repeat the
Vedant.
question? Sir, could you repeat the
What
question?
point P prime? The point P prime is at rest, right?
Yes, sir.
So if point P prime is at rest and I am viewing the body from point P prime, then what kind of motion the body will be in? What motion is the body exhibiting? Rolling motion, rotational motion, translational motion, pure rotational motion, pure translational motion. Take your pick. Topics.
The translational motion.
Okay, Adesh, tell me, dear.
So I'd say pure translation motion towards the yeah, in anti-clockwise, towards
Pure
minus I
translational
can.
motion, pure
Pure
translation.
translation motion.
Come again.
So I'd say translation motion.
Okay, what is P prime state? P prime is moving or is at rest?
So it's
Adesh and
moving.
Vedant, what is
Like,
the state of P prime at that instant? At that instant,
so at
only at
that
It
that.
is
instant
at
it's at
rest.
rest.
At
It is
rest.
at. And what is the state of other points? Are they also at rest or they are in motion?
So at that instant, all the points are at rest.
At that instant, all the points are at rest. Means no,
So
none of the point on the body is moving at that instant.
uh,
None of the point. That means you. That means are you of the opinion that if the tire is rolling on ground and the point which you are to read it against, which is in contact with ground, is at rest, then every point on the tire will be at rest.
no, sir, no, sir,
That is what you are indicating, right?
no,
Yeah.
sir, no, sir, no, sir.
Is in touch with ground is ought to be at rest. So that is at rest. What about the other points? Are they also at rest?
No, sir.
So actually, they
Okay.
are at rest, right?
What you
Because
say? What about the other
I,
points? Are they at rest or they are in motion? Tell me that first.
Sir,
if at that
Uh,
particular instant, so since it's
Yeah,
a
that
rigid
instant
body,
only. That instant, when I say that instant, it is about that particular instant when P prime was touching ground. So
so
P
it is
prime
at rest.
was
All the
touching
other
ground.
points are also
What
at
about
rest.
point at the top? Can you say point at the top was at rest at that time?
No.
So point at the top was moving, right, Adesh?
yes, sir.
Okay. This point was also moving, right? Vedant?
Yes, sir. Yes, sir.
What about this point? Adesh, tell me what about this point? Was this point also moving?
Yes, sir.
So can we say all the points barring P prime were in motion?
Yes, sir.
And if all the points barring P prime were in motion, then what kind of motion will it be? Think about it and tell me the correct answer now to this question. There is one point which is at rest. Rest of the points are moving. And moving about which
Pure
point they are?
rotational motion.
About this point. Because this point is at rest, but I find all the other points to be moving. So what motion will it translate to? Come on, tell me. What motion it will translate to? If I see a body of which one point is at rest and all other points are in motion, then what motion I am to get? What kind of motion I am to get? Come on, think it over, dear. You will not
Sir,
be getting in this detail anywhere. You are to apply your faculties. Try understand. Krish, please hold yourself. Try understand. You will have to apply your faculties to get what I'm trying to get from you. It is very easy to get from teachers. I wish you get me. Okay? And
Yes.
you are then to explore more horizon than what otherwise. Please try to understand where my question is coming from. My question is coming from a basic understanding on how the tires on the roads are in motion. A point which is in touch with ground, is at rest. Okay. Rest of the points are moving good. So if I am to ask you that at that instant, P prime was at rest, this was moving, this was moving, this was moving, taking any point, they were all into motion. Then what kind of motion you will say the body was executing at that time? How will you see this to be moving? You will see this to be moving this way. You will see this to be moving in some direction. So every point is moving, barring one point. Spare a point and leaving that point, all the points are in motion. So what motion you are to get for the system taken?
Rotational motion.
The rotational motion.
Rotational motion. So what will you say? Pure rotational motion. Can we say? Can we
Yes, sir.
say it will be a pure rotational motion? Think about it. Any point at this point is at rest and these are into motion. Correct, dear? These are
yeah.
into motion. Correct? So what kind of motion this is to get you? Look at the fan overhead. You will get to know what kind of motion you are getting about shaft. Shaft is at rest. Correct?
Yes, sir.
Yes,
And barring the shaft, every point on the blade is in motion. Correct?
Yes, sir.
Yes, sir.
So what motion is that for you? Is it not pure rotational motion?
Yes, sir.
So what can you collate? Now, if I'm asking you to amalgamate our thoughts and tell me something on instantaneous axis of rotation. Can you collate, can you reconcile and get me a statement on instantaneous center of rotation? Any one of you? I want one statement on instantaneous center of rotation. What it is what I want to know now. Why we are doing hammer and tong on this concept, what we gain of it, I'll reveal in few minutes from now. But for
Sir, is it,
now, please collate your thoughts. Yes, Krish.
sir, is it like a point where the body undergoes pure rotational motion about which the body undergoes pure rotational motion?
Okay. Okay. Yes, Vedant, tell me, what say you? Do you subscribe to what Krish has said?
Yes, sir.
Okay, Adesh,
Yes.
would you get me your thoughts?
So, could you just repeat your question?
What is instantaneous point of rotation to you?
So it's that point which is at rest as compared to the body, or
Okay.
through, or it's the yeah, as compared to the all the other points present on the body.
Okay. And can you add to it?
So
About which the
the
body is in rotational motion.
Very good. About which the body for that instant is in pure rotational motion. Correct, yeah?
Yes, sir.
yes, sir.
About
Yes, sir.
which body for that instant is under pure rotational motion. Please highlight this point. Please underscore this point. This is how we define or find instantaneous axis of or point of rotation. It is that point about which for that instant body is under pure rotation. Am I clear?
Yeah, yes, sir.
Okay. So P prime, now tell me, and it goes to you, Adesh. I am writing this as 1 and I am writing this as 2. P prime 1 or P prime 2. Which one is to serve, or if both, you can say both as well. Which one is to serve instantaneous point of rotation? Yes, Adish.
So both of
P1
them.
prime is this to us when the body was rolling with slipping, right? Yeah, initially the body was rolling with slipping, correct?
Yes, sir.
Yes, sir.
And now finally or eventually the body was rolling without slipping, right, Adesh?
Okay, yes, sir.
So I
So
have marked this point deliberately as P prime 1 and this as P prime 2. Find here
yes, sir.
which do you bode well? Which of the 2 points augur well with you to be given the epithet of instantaneous point of rotation? Tell me, dear.
So P prime 2.
Okay, why not P prime 1?
So because for any so because so at that moment and when P prime 2,
You're
P prime
absolutely
1.
right on this. You're absolutely, without any doubt, no shred of doubt, you're right on that. P2 prime, fine. But why did you negate P1 prime?
So because the body at that moment is under rolling with slipping, right?
Very good. Because the body, when we were talking of the state initial, was under the impression of rolling with slipping. Correct, yeah?
Yes,
Yes,
sir.
Yeah,
sir.
yes, sir.
The body was under impression of rolling with slipping, then P1 prime cannot be at rest, correct?
Yes, sir.
Yes,
Either
sir.
it will slip forward or it will slip backward. Even that is known to us in which direction it will slip. Correct, yeah? We saw that
Yes,
yesterday. V naught by 2 I cap we got. Correct, yeah?
Yeah, yes,
yes,
sir.
sir.
Yes, sir.
It was slipping forward. So body cannot be said to be in the state of pure rotation about that point. Why so? Because that point itself is moving. Clear?
Yes, sir.
Yes, sir.
What is there? Got it, dear?
Yes,
Very
sir.
important. That's the reason I'm stretching and lingering on this concept. Are you able to understand the distinction that will be getting over here and other places? You will be able to solve questions after all these understanding on details and nuances. Am I clear, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, so when can we say that point qualifies being called or given the epithet instantaneous center of rotation? I think you all are now good with this concept, right?
Yes, sir.
Yes, sir.
Very good. So finally we got this, correct? Which I
Yes,
am to
sir.
prove.
Yes.
This I am to prove, but finally we got this. And initially, dear, initially I'll have to go back to the formula, correct?
Oh, yeah, yes, sir.
I have to go back to the formula. Is it okay?
Yes,
Yes, sir.
sir.
Yes.
Okay. L prime will remain the same. Omega naught minus k instead of omega naught, right here. L prime, yes or no?
Yes, sir.
Yes, sir.
L prime remains the same. Now we write the second one also as m v naught r in the direction k prime, correct here?
Yes,
Yes,
sir.
sir.
But here we cannot equate v naught to omega naught r, correct?
Yes, sir.
So we'll have to leave it in this form, right? Yeah.
Yes, sir.
Yes.
I'll have to leave it in this form. I cannot further. In want of getting instantaneous center of rotation, I cannot further. So I kept it to this. When did I get from this? When we were using V is equal to omega r, right? Yeah.
Yes, sir.
Yes, sir.
Yes, sir.
So this is the initial angular momentum. This is the final angular momentum. And we know angular momentum will remain conserved, correct?
Yes, sir.
Yes, sir.
Can
Yes,
we
sir.
equate initial with final to get omega? Can we or not?
Yes, sir.
Yes, sir.
So we can from here solve this question by using conservation of angular momentum as well. The question which we solved yesterday, we can solve it by a new concept, and that being uses of conservation of angular momentum. Clear am I on this one?
Yes,
Yes,
sir.
sir.
Yes, sir.
All of you?
Yes,
Yes.
sir.
And in the pursuit of solving this question, we have also made ourselves aware to the concept of instantaneous center of rotation. Can I take that for granted?
Yes, sir.
Yes, sir.
Adesh, can I take that for granted?
Yes, sir. Yes, sir.
Okay, so we are aware of instantaneous axis of or center of rotation. Good enough. Now, before I go for moment of inertia derivation, let us take two more questions on ICR. Write down. Instantaneous center of rotation. Instantaneous center of rotation can be found for any body. Instantaneous center of rotation can be found for any body by dropping perpendiculars to at least two velocities, at least two velocities, hence hence finding finding the point of intersection for these perpendiculars, hence finding the point of intersection for these perpendicular will get us instantaneous center of rotation, will get us instantaneous center of rotation. Now what I mean by that we got by logical interpretation, right? Yeah.
Yes, sir.
This
Yes,
that we did just now, what we did is something that we are well conversant with, a cogent case. Can I say? It's a very cogent day-to-day case. So you could have easily gauged on what can be velocity of point of contact. Correct, yeah?
Yes, sir.
yes, sir.
Let me ask you, what about instantaneous axis of rotation for a rod which is slipping against smooth wall and smooth flow? How will you decide on where will lie instantaneous axis of rotation for a rod which is slipping against wall, smooth wall and smooth floor? How will you locate? Tell me, can you spot ICR for this? Can you spot ICR for this experiment? Any one of you? Can I spot instantaneous center of rotation for this experiment? Any one of you can get me any hint? Anyone can play your hunch, dear? Go by your hunch. Tell me what can be the case.
So
It
will
is
it
still
be at the center of the rod?
this way and this is going this way. Yes, Adish, you are saying something?
So will it be at the center of the rod, or
What will it be? Come again?
will it be at the center of the rod? Because
Center of the rod here is not in motion. If I'm standing over here, Adesh, then will I say center of rod is stationary at any moment in time? At any moment you take, can you say it will be
yes,
stationary?
sir,
Sir,
keep falling.
sir,
The
sir,
very the very basic requirement fails over here to be a consideration meet.
sir,
Isn't it? Dear? You are falling short of meeting the basic requirement. Yes or no, Adesh?
Yes, sir, yes.
Okay, yeah, Krish, you are
sir,
saying something.
sir, is it like at a point above the rod? How would I show it, sir? So like you take a point above the rod, outside the rod, on the other side, on the other side.
Right,
Ah,
okay.
yeah, yes, sir, yeah, there, yeah, like that, yeah.
But there are myriads of point. Which point are you hinting on?
So the point where the perpendiculars will intersect.
Very good. And that is what I made you write. Please read all of you. What did you write? Perpendicular to at least two velocities, right? Yeah.
Yeah, yes, sir.
Yes,
So
sir.
velocity of this point is known to us A. It is in this direction. Velocity of this point also is known to us B. It is in this direction, right here. And then we draw perpendiculars to that velocity. And perpendiculars means this is the perpendicular to velocity at B. This is the perpendicular to velocity at A. Wherever the perpendiculars are to meet, that will be ICR. That point will be instantaneous center of rotation. You are immediately to rebut and ask me why, isn't it? If you are inquisitive and you should be inquisitive being students, you should ask me why will that point be taken as ICR, correct? Yeah.
Yes, sir.
Yes,
Yes,
sir.
sir.
So what is the justification for that point to be taken ICR? I will ask you, if the body is moving on a circle, think about it, a particle, take a particle to begin with. If a particle is moving on a circle, let us say this particle is moving on this circle, right? Okay.
Yes, sir.
Now,
Yes,
velocity
sir.
here, whatever velocity here, correct?
Yes, sir.
Yeah, yes, sir.
Drop perpendicular to the two velocities shown. Drop perpendicular to the two velocities shown. Where will they meet? Here?
At the center, yeah.
Yes, sir.
Is it not the point about which body is parangling?
Yes, sir.
Is it not about point about this? This is the point O. Is not O a point about which point P is parangling, rotating? Yes or no? Can you say that?
Yes, sir.
Yes, sir.
And can you also say that O should be at rest?
Yes.
Yeah, yes, sir.
So
Yes,
it's
sir.
center.
How can we make that claim? How can we stake claim to O being at rest? One is velocity and the other is radius. How I know they are 90 degree to each other, right? Yeah.
Yeah, yes, sir.
Yes, sir.
So the moment you are drawing perpendicular to velocity, look over here and compare it with this case, correct? Yeah.
Yes,
Yes,
sir.
sir.
Perpendicular to velocity, where they meet here, and about this point, body is into pure rotation. Agreed?
Yes,
Yes,
sir.
Yes, sir.
So perpendicular to this velocity, perpendicular to this velocity, wherever it meets, wherever the two meet, that is the point about which body is under for that instant pure rotation. Agreed?
Yes, sir.
Yes, sir.
Yes, sir.
Yeah, are you getting it or not? Please try to find a cube. Take a cube from here. Are you getting it? Draw parallel with this case. All of you. Draw parallel with this case. Take a cube from here. Any pure rotation motion. Remember, look at the fan overhead. Any pure rotation. Take a point on blade. Take a point on blade of fan. This is the blade of fan. Take any point on blade of fan. If I take this point, any point you take. Here velocity and radius, they will make 90 degrees. See for yourself. Velocity here and radius, they will make what angle? 90 degree with each other. Take any point, right there.
Yes, sir.
Yes, sir.
And why I'm able to find a situation as being shown on board is because fan blade, any point on the blade of fan is in pure rotation, correct?
Yes, sir.
Yes, sir.
So when the body is under pure rotation, then velocity and perpendicular drop to velocity wherever they are to meet. That is the point about which body is executing pure rotation. Am I clear on this one?
Yes, sir.
So whenever I am to find ICR, what shall I do? Whenever I am to find ICR, mathematically when I am to find ICR, instantaneous center of rotation, then what shall I do? What shall I do? What should be the aim? The aim should be to find velocity of any 2 points of the body, correct?
So one doubt.
Huh.
So is it necessary that the velocity should be the same?
No. I didn't say that. Did I make you write it?
No.
Did I make you write that velocity must be same?
No.
No way. Nothing about velocity being same or different. Only
Yes, sir.
that you ought to do, you ought to drop perpendicular to two velocities. That's it.
Yes, sir.
So draw perpendicular to two velocities, you are to get instantaneous center of rotation.
Yes.
Okay, wherever the two perpendiculars are to meet, that is the point which we are to give the epithet of ICR. Clear here?
Yes, sir.
Yes, sir.
Okay, so is ICR clear to all of you?
Yes, sir.
Yes, sir.
Instantaneous center of rotation clear to all of you then?
Yes,
Yes,
sir.
sir.
Yes, sir.
Or-
Yes, sir.
Yes, sir.
Okay. Okay, good enough. So I asked you a question over here. The question being, if this is ICR, the state is given to you, this is ICR, instantaneous center of rotation. If this is instantaneous center of rotation at t equal to some time t, then show the direction of velocity of center of mass of the rod. Show the direction of velocity for center of mass. Anyone? I'm going by reverse logic now. I'm taking reverse logic. I'm going by reverse logic. Think about it. What I'm trying to suggest. I have given you ICR and I want velocity of certain point. Can you get me velocity direction? And if
Okay.
possible, magnitude.
So
Anyone?
you can draw perpendicular from ICR onto the 2 points of where it is contact
Perpendicular from ICR on this point.
to the point to A and B.
Okay, I drop a perpendicular to this point to the rod A and B. Fine. But that perpendicular will meet center. Why? Because this is forming a rectangle. Correct? Yeah.
Yeah.
So that perpendicular, if I'm drawing perpendicular, it will pass through center of mass. Okay. Are you in
Yes, sir.
agreement with this?
Yes, sir.
Okay. Fine. Then.
Sir, I meant not those two, sir. The two end points.
Acha, I'll draw perpendicular on those. Fine. This is the end points I do draw. Then.
Then you can find direction of velocity. So it'll be like the other way.
Velocity of what you want? A and B.
Yeah, yes, sir.
No, velocity
Yes,
of A and B are given to you. B
Oh,
and
yeah,
B are
okay.
given.
Okay.
VA are given to you. I want velocity of center of mass.
Mass. Okay.
Or
Ask
will
me
it?
ICR. In which direction should be velocity of center of mass? In fact, halfway you have
Sir,
asked me to drop. You asked me to
sir,
drop perpendicular. I have dropped perpendicular past the center of mass. Yes, Adesh.
so I have one logic, but I'm not sure if it's correct. So we take at another point of time. So then, for example, point B will be a bit lower. Point A will be
Okay.
a bit further over there, like
Okay.
that. Yes, sir. So then again, when we draw perpendiculars from
Okay.
from those 2 points, so and then we join the initial ICR to the final ICR.
Uh-huh.
So when we join the initial,
Okay,
those
fine.
two, and that direction won't we get the motion of center of mass?
The center of mass, you will see center of mass, Adesh. Then center of mass will be moving in a circle actually. Center of mass will not be into translational motion. Center of mass, and we can see that center of mass will be in what kind of motion? Center of mass will be in rotational motion. Anyway, that is to be seen later. My simple submission being, what all we have studied, based upon that, if I am able to find velocity of center of mass, even direction wise, I am good. What all we have studied based upon that, only direction. I'm not asking for magnitude. Magnitude, all the more the merrier. But just the direction, if you can get me, of center of mass motion, and that is not very tough ask. Why is not very tough ask? Because velocity and perpendicular to velocity will meet at center of mass, correct? Yeah.
Yes, sir.
We are known to that velocity of any point and perpendicular drawn to that velocity will meet center of mass somewhere, correct? Center of mass, sorry. I see are somewhere, correct?
Yes, sir.
So if this is the perpendicular, if you drop a perpendicular, then you can very well say that this perpendicular will pass through center of rod. Tell me why I'm saying so. Why I'm saying that perpendicular will pass through center of rod? Because this forms a rectangle, right there.
Yeah, yes, sir.
Rectangle, and this is the diagonal, right? So it will cut the center in two halves and cut it at 90 degree. Correct? The property, mathematical property, right here.
Yes, sir.
So it is 90 degree and it is passing through center. It is ought to pass through center, correct?
Yes, sir.
Yes.
So in a way, this is ICR which is known to us, and this is perpendicular, correct?
Yes, sir.
ICR is at rest, and this is the perpendicular distance L by 2, correct?
Yeah, yes,
So
sir.
velocity of center of mass should be in which direction? Should be in this direction, correct?
Yes, sir.
Velocity of center of mass, the only direction possible for velocity at that instant is perpendicular to the line joining ICR and itself, correct? Yeah.
Yes, sir.
So VCM will have what direction to its merit at that instant? Only this direction. Are you getting it, Adesh? Is it clear? These are a few points they can raise questions on. Am I clear on this one?
So magnitude of VCM will be VA plus VB.
VCM magnitude will be omega into L by 2. Omega into L by 2. Omega R. R is L by 2 and omega we need to find. Omega means how is rod rotating. Clear here? So
Yes, sir.
omega we can find but not finding now. Not known to you now. If omega given, you will multiply omega with L by 2. That will be its magnitude. Is it okay?
So by
Yes.
vector addition, won't VCM be equal to VA plus VB?
No, it will not be. Why will VCM be equal to VA plus VB? VA depends on Y.
Yes,
What
sir.
is VA? Minus of dy by dt. And VB depends on X. What is it? dx by dt, right?
Yes, sir.
And what about this point? This point depends on the angle, right?
Yeah, yes, sir.
So x coordinate of this will be x by 2 cos theta, right? Yeah. And
Yes,
y
sir.
will be y by 2 sin theta, right?
Yeah, yes,
Yes.
sir.
So you'll have to differentiate x by 2 sine theta, and theta is also a variable, right? Yeah.
Yes, sir.
Yes, sir.
So when you will differentiate, you will have to use UV form. So you cannot say that will be vector sum of only VA and VB, right? Yeah, right, Krish?
Yes, sir. Yes, sir.
Be very careful, okay? These are to
Yes.
come in form of questions, but as you are asking question, good that they are getting for some point I may miss. So whatever question is there in your mind, please feel free ask. Is it okay? There
Yes.
are, among us almost gigantopolitis concepts that you are to summarize through questions. So if I may miss on anything, you please pontificate. For example, you are of the opinion VAVB, please spell it out, whatever opinion you are at. You may be wrong, you may be right. Right? No issue. If you are wrong, then we will add to it. Correct, yeah?
Yes, sir.
Yes, sir.
Because VAVB will be, if you differentiate, which we'll be doing in the questions by the way, dx by dt, right there, into cos theta plus x by 2 minus sine theta into d theta by dt, correct?
Yes, sir.
So this is how you will get to know what is dxcm by dt. It will have a term d omega by dt, and d omega by dt means how is rod rotating with time. So those we are able to get as and when it falls. For now, it will not be VA plus VB. Anyway, getting back to the concept of instantaneous center of rotation. Am I clear?
Yes, sir.
Yes, sir.
Sure, dear, there is no element of doubt on ICR.
No,
No,
sir.
sir.
Number of questions are to be positioned on ICR, let me tell you. So there should not be any element of doubt on ICR, instantaneous center of rotation. It is not to say that ICR will always fall inside of the body. As you can see over here, it is falling out of the body, correct?
Yes, sir.
Yes,
Yes.
sir.
Okay, so it can fall anywhere. You have to find ICR and you know the methodology of finding ICR. If someone asks you what on earth this ICR is, I presume you will be able to satisfy that person on concept, right?
Yes, sir.
Yes.
Okay. Shall we keep to this today so that you can ponder on ICR or
Yes,
should
sir.
further?
Sir, anything is
You-
okay.
So I'm kind of free. I have Alan and Python, so I'm free now.
I could get you, dear Adesh. Please be clear. You're not audible.
So I'm free now. I mean, we can continue also. I have class at like 5, Alan.
You are not. Can you type it, Adesh? Can you text me? Can you text what you are asking? Because
So,
getting an echo. Huh. Yeah, say. Just speak, Adesh.
so I'm free right now. We can continue. So you are asking, right? Or should we
Okay.
continue?
Okay, fine. In that case, we are continuing. So this is ICR. Now let's further write down. There are two particles A and B. There are two particles A and B connected by a light rod. There are two particles A and B connected by a light rod of length L. Of length L. An identical particle. An identical particle moving with velocity v naught. An identical particle moving with velocity v naught hits particle A, hits particle A and sticks to it. Hits particle A and sticks to it. Mind you, I'm saying particle, so you can discount on dimensions shown over here. Correct, yeah?
Yes,
As
sir.
I'm saying
Yes, sir.
particle, you can easily discount on dimensions shown over here. Clear?
Yes,
Yes.
sir.
Yes,
So
sir.
they are separated by a light rod, massless rod of what length? L. This particle comes, hits, and sticks to it. Clear?
Yes, sir.
Yes.
And entire of the experimentation is being performed on horizontal smooth table. Clear, dear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Experimentation is being performed on horizontal smooth table. Okay. Find find the angular speed. Find angular speed of given system. Find the angular speed of given system just after collision. Find the angular speed of given system just after collision. Now let me make a disclaimer over here. And the disclaimer being, I want to solve this question, but I want to juxtapose it with what we were studying. And what we were studying is known to all of you. It being conservation of angular momentum, right? Yeah, that is what we began the class with, correct?
Yes, sir.
Yes, sir.
So conservation of angular momentum holds good if and only if we are able to identify a point, correct? We are able to identify a point about which torque due to external forces on the system is zero, correct?
Yes, sir.
Okay. So which point should I take over here as the point about which torque due to external forces is zero on the system? Not to lose the sight of everything being conducted horizontally. That means it is on horizontal table, which is being smooth on nature, correct?
Yes, sir.
Okay, so being smooth on nature, of course, it is not to apply friction, correct, dear?
Yeah, yes, sir.
Yes, sir.
There is no friction element anywhere. Horizontal is the orientation. Particle goes, hits, and sticks to A. What can you say should be taken over here as point of angular momentum conservation? About which point torque due to external forces being zero on system according to what you reckon. So how many forces are acting on the system, by the way? Normal and mg, correct?
Yes, sir.
Yes, sir.
Forces, if you're talking of only external forces, and I have taken ABC, all being system party, clear, dear? I am saying that system entails ABC and light rod, fine?
Yes, sir.
Yes, sir.
And in that case, the only forces which I do have being normal and mg as external, correct?
Yes, sir.
Yes, sir.
So normal and mg cannot produce any torque in k direction. That means perpendicular to the table. Think about it. Can it produce any torque in k direction? Torque means cross product, and cross product can never be in the direction of forces. Correct, dear?
Yes, sir. Yes, sir.
E equal to A cross B, and C can never be along A or B. Correct? It will be always perpendicular to A and B. Vector concept.
Yes, sir.
Correct, yeah.
Yes, sir.
Yes, sir.
So mg acting normal to table. Normal acting normal to table. Right, dear?
Yes,
Yes,
sir.
sir.
All by can never be normal to table. Correct? Yes or no?
Yes, sir.
Yes, sir.
So there will be no point about which torque due to mg or normal is normal to table. Agreed or not?
Yes, sir.
Okay, so you can say that there is no torque due to mg and normal, right, dear?
Yes,
Yes,
sir.
sir.
So if there is no torque that mg or normal can register, then you can conserve momentum, angular momentum about any point.
Yes, sir.
So if we can conserve angular momentum about any point, let me ask you, can I conserve angular momentum about point P, P being the center of rod? Can we conserve angular momentum about point P, P being the center of rod? Yes or no? Think about it. Can we conserve it about P? And here comes the concept which I made you understand the very first day or second day. When we were dealing with torque here, I told you that torque is equal to R cross F, okay. But that is R cross F only if you are in inertial frame, correct?
Yes, sir.
So if you are in inertial frame, you can write without any doubt, unflinchingly you can write that torque is equal to R cross F. But if you are in a frame which is non-inertial, then what did you have to add to it?
So you have pseudo force.
Add to it torque due to pseudo force, correct?
Yes, sir.
Yes, sir.
If I am at point P and I am on the rod, if I am at point P and I am on the rod, what frame I am in? I am certainly in non-inertial frame. Clear? I am certainly in non-inertial frame. Why did I say so? Because the particle will come hit and the rod will not only move forward but also rotate. Correct?
Yes, sir.
About it. Particle arrangement this, it hits. So the rod is moving forward and it is also rotating. Correct? Yeah.
Yes, sir.
So point P is what point to me? Point P is non-inertial point to me. Suddenly it started moving, right? Yeah, from zero velocity to some velocity. So what kind of point it is?
The
It is
non-inertial.
non-inertial.
No, sure.
It got accelerated, correct? Yeah, from zero velocity to v velocity. So it got accelerated, correct? So what kind of point is that? That is non-inertial point. Agreed or not? It has
Yes,
got an
sir.
acceleration to its merit, correct?
Yes, sir.
Yes, sir.
It is a non-inertial point. Then I have to look for torque not only due to normal and mg, which we know they are to be zero. Torque not only due to normal and mg, but also torque due to pseudo force, correct?
Yes, sir.
Yes, sir.
Yes, sir.
Now, torque due to pseudo force is a pain in neck, is a cumbersome ask. It's an onerous ask. You cannot calculate. It's very difficult to calculate torque due to pseudo force. Why? Because pseudo force itself can change with time. Think of it. If I'm over here, then I'm accelerating. Let us say I'm moving upward with acceleration A. Is it okay?
Yes, sir.
Upward means away, not upward, away. Is it okay? It is moving
Yeah.
this way. Right? So away from me. The rod is moving away from me. Is it okay? Away from me. Are you getting it?
Yes,
Away
sir.
from
Yes, sir.
what acceleration? A. So if the rod is moving away from me with A acceleration and I'm on the rod, then I'll find all the points to be moving downward with acceleration A, correct? Yeah.
Yes, sir.
Yes, sir.
So there'll be a pseudo force which will act on this particle in this direction. And what is that
Yes.
pseudo force will? M into A, correct? Yeah.
Yes, sir.
Yes, sir.
And this pseudo force will very well produce torque about this point, agreed or not?
Yes, sir.
So I will be in no position to say that torque due to all the forces are zero, agreed or not?
Yes, sir.
Yes, sir.
Yes, sir.
If we talk due to pseudo force, are you getting it, dear? Please see it with certain precision. You are to find the distinction between points, class. Because the questions are very pontificatingly asked. Why can't you take point P to conserve angular momentum when normal cannot produce torque, when mg cannot produce torque? Then why are you discounting on point P? Why are you dismissive about point P? So what are you to tell the author? You have to tell the author that P is a non-inertial point. And if I take
Yes.
non-inertial point about which I am calculating torque, then I'll have to calculate torque due to pseudo force as well, correct?
Yes, sir.
Yes,
Yes,
sir.
sir.
Torque due to pseudo force will not be zero. And if torque is not zero, then I will not be able to conserve angular momentum, right dear?
Yes, sir.
Yes, sir.
So for conservation of angular momentum, I should find a point about which torque due to pseudo force is zero. About which torque due to pseudo force is zero. I'll have to find a point about which torque due to pseudo force is zero. And then comes to us, very important point. Then comes to us, pseudo force acts at which point? Write it down. It can be proved, and very easy is the proof. I'll ask you to try once. it can be proved that pseudo force, and I'm making a change over here now. Look over here. It can be proved that pseudo force passes through center of mass of a system. It can be proved that pseudo force passes through center of mass of a system. Now look over here. I showed over here pseudo force, right? What shall I do now? Where shall I show pseudo force acting? Center of mass, correct?
Yes, sir.
And where will I center of mass? M. So M into 0 plus 2M into L divided by 3M. Can you relate to this form?
Yes, sir.
Adesh Vedant, can you relate to this form?
Yes, sir.
This is my
Yes.
frame and this is 0. So M into 0, 2M, they have stuck, isn't it?
Yes,
So
sir.
2M into L divided by 3M, right?
Yes,
Yeah.
sir.
Yes,
So where lies center of mass? 2L by 3. So from here at a distance 2L by 3, correct?
yes,
Yes,
sir.
sir.
That means this will be L by 6. Check it out. Check it out here. Endorse me on this. This will be L by 6, this distance, correct?
Yes,
Yes,
sir.
sir.
Yes, sir.
So this will be how much to us? L by 6. This is center of mass of system. Can we say that? Visible?
Yes, sir.
Yes, sir.
Visible to all of you?
Yes,
Yes,
sir.
sir.
Okay, what is that to be called or named henceforth? Center of mass of system. Can we say that?
Yes, sir.
Yes, sir.
Center of mass of system. And if this is center of mass of system, then pseudo force should pass through it, right?
Yes, sir.
Right, sir.
So pseudo force will be shown here, this way. What will it be? M into ACM, not M into 3. 3M into ACM, correct?
Yes, sir.
This will be the pseudo force shown by parallel lines. Is it okay, dear?
Sir.
Yes, sir.
Yes, sir.
Okay. So if I choose this point, then I'll have to calculate torque due to pseudo force as well. You know that is a contention, correct?
Yes, sir.
That was one of contention. So tell me which point shall I choose? So that torque due to not only normal and mg is 0, but also is 0 due to pseudo force. Come on.
The center of mass.
Very good. And remember this forever. Always choose center of mass of system. Because center of mass when you choose, then you absolve yourself of pseudo force torque. Is it okay?
Yes, sir.
So center of mass if I choose as the point about which I'll conserve angular momentum, then I have abdicated completely myself of the responsibility finding torque due to pseudo force. As pseudo force will produce zero torque. Agreed all of you?
Yes, sir.
Yes, sir.
Yes, sir.
Then can we say about this point angular momentum can be conserved?
Sir?
They are not
Yes,
about
sir.
this point angular
Yes, sir.
momentum.
Yes, sir.
Which one? This
Yes,
point
sir.
center of mass of system, correct?
Yes, sir.
Yes,
So
sir.
we
Yes, sir.
have angular momentum about center of mass of system. Write them down. What will be angular momentum initial? Of the two masses, 0, they were not moving. And what will be angular momentum of this mass which was moving? mv naught into how much will be this? L by 3, correct?
Yes, sir.
Perpendicular distance, angular momentum is linear momentum into perpendicular distance, right? Yeah.
Yeah, yes, sir.
Yes, sir.
So the two masses 0, but of this mass as it was moving, mv naught into what we will say L by 3. Check it out here. Is it okay?
Yes, sir. Yes, sir.
Okay. And then after of that we go for final. Now finally about this point system started rotating. Is it okay? With omega let us say. System started rotating and rotating with what? Omega. About any point you take, omega will remain the same. Omega doesn't change, remember. If you are on the body or you are above the body, omega remains the same. Is it okay?
Yes, sir.
Yes, sir.
Now tell me, final angular momentum if I am to write, then can I write I into omega straight away? Because this is the rigid body and it is fixed. This is
Yes,
to
sir.
you.
Yeah.
This is to you the point where you are present, and you are present over here. About this point, the body, the system is rotating. Correct, dear?
Yes, sir.
Yes, sir.
About you, the body will be rotating. Eventually, it is rotating. Finally, sorry, initially it was only this particle to carry momentum, which is what you wrote. Correct? Angular momentum. Correct?
Yes, sir.
And
Right, sir.
finally, from the body, you find body to be rotating with omega. Correct, dear?
Yes, sir.
Yes, sir.
If you are on the body, you know. If you are on the body, you know you don't qualify registering rotation. Sorry, translational motion of body. Correct?
Yes, sir.
Yes, sir.
So for you, body is in the pure rotation. Agreed or not? Because you are on the body. Clear?
Yes, sir.
Yes, sir.
Look over here. If you are over here and the ruler is rotating, you are at the center of a stick, and the stick is rotating. Then will appear to you this end rotating and this end also rotating. Correct?
Yes, sir.
If you are on the same stick and you are standing over here, then will appear to you only this to be rotating, this to be at rest. Correct?
Yes, sir. Yeah.
Yes, sir.
But in either case, manner will change, and manner is subject to your position. That is fine. But in either case, omega will remain the same. Clear?
Yes, sir.
Yes, sir.
From here, you look from here. Till the time you are on body, or even if you are off the body, omega will remain the same. Only in one case, omega changes when you are looking at the body this way. Then the body will appear only moving up and down. Okay, so it is rotating. I'm looking. To you it is rotating. To me it is not rotating because to me the body is just moving up and down. Is it okay?
Yes,
So
sir.
only
Yes, sir.
barring that case, omega will remain the same. You are on the body or off the body. Clear? Am I? Am I clear?
Yes, sir. Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what we can say about this body? Now I'm at this point and the body is rotating with omega. So can I use I into omega as
Yeah.
angular
Yes, sir.
momentum?
Yes, sir.
Okay, so I will be what to us for these two bodies 2m into L by 6 whole square plus for this body m into how much? 2L by 3. 2L by 3 whole square. Right here, this is I
Yeah.
and
Yes, sir.
square and into omega. I, all of you do know ml square. Correct here?
Yes,
M
sir.
into perpendicular distance square. So over here, the 2 points are 2m and L is how much? This will be L and this L will be how much to us? L by 3, correct? L by 3. No? This will be L by 3.
Yeah. Yes, sir.
This will be L by 3. And then for this point, this will be 2L by 3. So 2m into L by 3 whole square plus m into 12 by 3 whole square into omega, correct?
Yes, sir.
Yes,
Is it
sir.
Rakesh? Vedant, check once there. Is it okay? This is one of a kind problem which I have also, I think I have uploaded this question to you yesterday. Check
So
it.
how is
Okay.
it square, sir? MR square omega.
ML is square, moment of inertia is ML square only.
Yes,
MR is square. M is mass and R is perpendicular distance, right?
yes, sir.
So M is mass and this is perpendicular distance.
Yes, sir. Yes.
Center of mass. For first body, for second body it is 12 by 3. For first body, M and M added, so 2M. And how much will be this distance? L
Yeah.
by 3.
By 3. Yes, sir.
So that is what we have done, isn't it? N to omega, this will get you omega. V naught by 2L, I think will be the answer. Omega is equal to V naught by twice of L. Is it fine?
Yes,
Yes.
sir.
These are the questions there which are to open your concept. Remember, these questions are being solved in class, not as questions, but these are imperative on you to open concept related to center of mass, omega, and whatsoever fall in the pursuit of solving them. So please pick
Yes,
on the
sir.
numerics. Is it okay?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay, let us keep to this today then.
Yes, sir. Thank you,
Okay,
sir.
thanks, class.
Thank
Yes,
you,
sir.
sir.